beginning, I built tools to talk to the cube and from the controller to the cube and just the controller itself. And then, we all worked in a room and like literally would go and work off of different animations and take the tools I made and just like work with and see what they could turn on. And then at the end, we put the switch in and I compiled all of them into like a program routine so I can press the switch and you change the programs that they wrote.
Yeah, I mean, we started relatively like basically doing the multiple serial input lab and just kind of like, okay, how are we going to get all these sensors to talk to processing, and then we're like, are we going to use processing and like have processing take the values and then output the values to the cube? Can we bypass that? And so we kind of took it one step at a time, kind of that way. And then once we sort of got each part moving, kind of took it apart and figured out one step. Like then we got the sensors talking, so then we needed what they needed to talk to. So we got the cube working, and then iterating over how we're talking to each one. And then there was like a long time where we couldn't talk to just one LED. We figured like just racking our brains on how to make that work, and then finally got that working, and then sort of how to put all that together, and then sort of just one step at a time. Kind of we'd come back, go until brains were mush, go away, go get some sleep, and then come back, and we'd all have new fresh ideas to turn it in.
There's a lot of prototyping. So, we built programs that let's just test the sensors. Are we getting readings from the sensors? Okay, so like we built like a gray box tool. So it's like you see processing like a grid of 6 squares, and every time you press on it, you'll see the squares change from black to white and all levels in between. And all right, squares are working, and then we'll have one just for the LEDs. And does the LEDs work? And we'll run through each LED in a sequence, and that works. So that was like every time the next day would start, we load up those 2 programs and make sure they work. So everything's working. Now we can start playing with programs and animations.
Well, yeah, all of our problems that we had ended up being in processing, which was great, because we're always worried that it's going to be the wiring, because there's a lot of wiring happening in there. So there were points last night where we would keep running those like test codes, and those are really handy to have.
Yeah, I think those are really essential on any reasonably complex project. And where do you want to go with it now? Or do you?
Bigger.
Addressable
LEDs.
Yeah, bigger addressable LEDs. I mean, whenever people come up and touch the thing, they're like, this would be so awesome if it was all around me, and kind of like just more and more and more. And so I think this is a good sort of step towards in that direction, and kind of having something that you can really touch. That, I mean, the feedback is really instantaneous on the cube, which I think was great, and I was really happy that we were able to achieve that. And sort of being immersed in an environment that's lighting up all around you, and you're being directly affected, and also adding some sort of life to those LEDs, so it's not just on-off, it's more kind of like phase and things like that. I think is a direction to take it.
We had initial visions of building like a huge life-size square that you could walk through. And actually the installation of Madison Square Park very much sort of captures that. I saw that one night walking through what's running across along, so I was so excited. We did some other research and found similar pieces that sort of reflect sort of your physical space. So we thought about maybe trying to hook it up to Bluetooth so you could carry the controller through as you're walking through a 3D space. So, yeah.
Sure, but what this does is nice. It shows the value of a scale model in a sense, because now you have a sense of the basic control of the whole system, and scaling up would bring with it all of the issues of architecture, and I mean physical architecture, that you'd have to consider. But at least you have a system as a base place to start with.
Yeah, and a lot of code is designed to be scalable. So the sensors, everything's dynamic. So number of sensors, number of LEDs, number of pressure levels, even the program switches.
And also, even with this just scale model for making it brighter, we wanted to give it more power, but we also wanted to have something to present. So we didn't give it more power until after this class. We're going to try to build it, or see how much power we can give it.
That's a wise decision.
We figured we just dim the lights and go.
Sure. I hope that it doesn't blow up, but I think that was a wise decision on those. Any other questions, comments? Yeah.
Yeah, I was a little confused. Why is it that they're not going as bright as you want them to?
Because each LED is only on 1/64th of the time, and even slower actually once it's processing all the sensors and doing that. Because it turns one on and then goes to the next one and decides whether it's on or off, and then loops through that as fast as it can. But there's a bit of delay in there to make it be a little bit brighter, so it's like instead of it just being on for almost no time, it slows the whole thing down just a little bit and gives it just a little more time to be its full brightness, but then it just is off for the rest of the time.
So is that an issue with the processing speed of the Arduino?
No, that's actually an issue with the architecture of the whole system. The Arduino can go faster, and this is what Doug was just getting at. But when it goes faster, the LEDs are on and off such a short time that you don't see them. So they're actually slowing it down to give you time to see the LEDs. The multiplexer, on the other hand, can only turn on one LED at a time. And they've set up a row column scanning method, so they're scanning over a row and scanning over a column. Am I right?
Yeah.
So that therefore, they've only got control of one LED at a time. So if they used multiple Arduinos with 64 pins, for example, they wouldn't have that problem, but they would have the added expense of constant control of each pin. This is something you run into when you do things in multiples. What I'm getting at is that in order to have control over a single output all the time, that costs a certain amount. So the solution is usually, can I afford to not have control all the time and knock my cost way down, but I compromise on things like brightness. Does that make sense? Cool. There's another question over here, Jason.
Yeah, can you tell us about the construction of the controller?
So we, early on, kind of tossing out like how to control different things, what we liked. And I had always been interested in kind of like 3D space and kind of how to sort of take, the mirror, but then kind of add this other element to it. So originally we wanted to maybe affect that box, but then doing the math, there are more than 2,000 pins on that box, so adding actuators that could move 2,000 pins the way we wanted to was not in the cards. So we thought about flipping it around, and we actually sort of toyed with it and kind of playing with it. And Tom helped us out with the idea of putting a foam behind it, kind of, memory foam, so if you put your hand in it, it would, translate how the foam works. And actually, memory foam didn't work as well. It was kind of just a cheaper, more springy foam, because it kind of gave you that feeling of bouncing back. So we went to Canal Street Rubber and Foam, and we're just like touching the thing, had the thing with us, and we're seeing it go
Nice.
through. And then sort of once we got that together, we were able to use the original construction, because it's got a back plate under the pins about an inch from where the pins are when they're full up. And so we were able to find just inch foam and slide it in, and then the FSR sat just flush against that back plate.
Right.
And then creating the box around it. I used to be a metal fabricator, so I called in a favor from my boss, and he had some 1/4 inch steel.
And the soldering of the cube, how long did that take? That's amazing.
So I used I drilled a sort of a jig, to do each layer. And so then I just went through and bent the cathode of each LED I was using one direction, so I knew which one was which and how it would go. And then I just kind of like stuck them all in the jig, soldered one by one, and then kind of made just a square, and then added one on top of the other, soldered. And there's actually all the connections are just the LED connections, except for one row. There's a support wire that just allows it to be a little more structural.
Did you test them as you were going through? I mean, like, how did you know when you were done? Like, wow, what if I, got like 3 LEDs out of order? Like,
If I got one backwards.
yeah, exactly. Or like one's burned out. Like, would you have to?
There was a backward one.
Yeah. Wow.
That's where your diagnostic program comes in, right?
Yeah. So there was a backwards LED, but fortunately it was on the outside. So it was, but we left it in there. So you know what? It's like it's working. Amazingly it works.
It's
So,
amazing.
but I was very careful, like because you can see the anodes as they go down. They have to go around the LED below it, and so just a lot of like soldering and small needle nose pliers to put them in the right place. And, good use of helping hands. And, a long time in the shop, just waiting till I clean up all night.
One thing I wanted to say that I'm particularly impressed with, the pin controller is kind of a holy grail physical computing project in that it comes up a lot. And these guys didn't shy away from it. They said, well, there's got to be a solution. And I like the solution you came up with because it appears to have more resolution than it does. Right? I think the way you handled it with the foam and the way you seem to be handling the code to read it is really quite smart because you can look and see there's 2,000 pins, but when you're putting your hand on it, you don't think about 2,000 pins. You think about here's the shape of my hand, and in that you think of maybe 20, 30 points. Maybe you only think of 5 or 10 at a time. Combining 6 sensors and looking at the relative levels of those 6 sensors actually allows you to produce a result that looks like you're looking at much, much more. That kind of technique is well worth considering in cases where you think you've got to give very, very fine control. What we've actually got to do is give control corresponding to what a person can perceive about the system. So I think you did a very good job on that, and kudos for that.
And one last thing also about the code. When we were struggling to get everything to light up and like match the sensors, we were just put on and then all of them would light up, or like some of them would skip and light up or something like that. And so we actually had to say for each sort of call that we did as we mapped out which sensor it would be, we had to say we had a function that was like write this number to our LED loop. But then if not, take that same number and write it to 0, because it was like on or off, and so we had to actually, instead of just not calling it again, we had to turn it on and then turn it off, because in the loop it would just kind of get all kind of crazy and just all light up, which was really pretty, but it was not it's like a,
Did not look controlled.
it did not look controlled.
Fair enough.
How did you think of the idea? How did you guys think of the idea?
Sitting in a room together.
Yeah. Doug sort of threw out the pin idea like very early on, and then we sort of ran with that. We're throwing out lots of different ways to sort of have the pin. And initially, as Doug sort of touched upon, we wanted sort of like 2-pin controllers, where like you stick your hand in one, and then like the pins move up in the other. So it's sort of like a ghost hand, like a phantom limb kind of thing. But again, we talked about it was going to be too complex to control each and every single pin. So we were like, okay, so we started researching and figured out the LED cube might be fun to play with.
And all of your ideas were basically spatial, so it sort of came from that.
Yeah, I think that was one of our driving things, was to like 3D space and how that can be affected or is difficult to affect.
Yeah, and I think there's a big difference between 3D space in computer terms and sculptural space that I think you've got now, which is good.
Could you use the foam technique to make the pins move now? Would that be something you consider doing? So like now, 6 sensors works really well, so maybe you'd only need 6 solenoids or 6 servos with foam underneath, and then you can get...
We've got a processing sketch that kind of maps out the look of what 6 sensors are doing. It's just these squares. And so we did think about using small inflatables, sort of to kind of map the pressure, but then thinking about pins and things that could pop. And so we kind of were like entertained for a little while, but we never really proceeded from there.